So the need for LSTM. LSTM stands for long short-term dependent. Sorry, this is memory, long short-term memory. So let's see, this is a many-to-many RNN, which we have seen. We have many inputs here, input words, and we are getting many outputs, right? Now, this is a single layer RNN. This is only layer. It is getting unfolded over time. This is time axis. Now, let's say this, if you see normally, this YI4 depends more on this XI4 input. Similarly, yi3 depends more on this and yi1 depends more on this, right? But in real life scenarios, this sometimes, this yi4 may depend more on this xi1, right? See, and rather than this xi4, this yi4 may depend more on this xi1, right? Now, but if you see this xi1 is impacting very less to yi4 because the distance between yi4 and xi1 is too much. Now these are only 4 time steps, but there might be, you know, up to 8, 10, 20 time steps in real life. So that time the distance might be too large between the yi this and this, right? So that means this xi1 is very impacting very less to yi4, right? So because there are lot of these outputs going from here, and these when we come here, this output has very less impact of this xi1. But what the point is, yi4 depends more on this xi1, right? Now the other thing is, let's say if we want to update this weight w1, right? Because yi4 depends more on this xi1. So when we want to update this w1, a small change in this yi1 will not impact this w1, because when we do back propagation over time, a lot of partial derivatives will be multiplied as we will go back from here to here like this. While calculating the derivative of loss with respect to W1, we have a lot of partial derivatives getting multiplied in order to update this W1. Now all the partial derivatives are less than 1 because the activation units may be sigmoid or tanh. That means this W1 won't get impacted, won't get updated uh, because of small changes in here, right? So that's so that is called as, the problem of long distance dependency, long distance dependency. So this RNN fails miserably, in this long distance dependency, because the distance, if this depends more on this, and the distance between these two is too large, then the updations becomes very difficult, and we cannot take care of this dependency, right? So that is one thing. The other thing, in now if you consider this RNN, again it's a many to many RNN, but this RNN is normally used in machine translation, right? Now again, let's say if you are translating English sentence to, let's say, German sentence, and sometimes happens this output word, this is English, this is German output from this English sentence. So this word depends more on this word. It might happen, but as again you can see, this distance is too large, too large. So computing this output solely dependent on this, or more dependent on this, is not possible, because of this long distance, right? So that is the problem of this RNN. And now the idea here is, if this is the dependency, can I somehow short circuit these all connections and directly be dependent on, directly create this dependency by short circuiting these connections, right? Can I directly have this dependency, right? So that's that means, as if this is more dependent on this, I should be able to neglect these connections, these, and I should be able to transmit this X directly to this, right? So that's what we want. That's what, in case of long term, long distance dependency. So this problem of RNN is can be solved or can be handled by using LSTMs, right? So that's where LSTMs are required.